Sodium is the 11th element on the periodic table with the atomic number 11. It belongs to group 1, known as the alkali metals, which also includes lithium, potassium, and cesium. Like other alkali metals, sodium is highly reactive, especially with water, and does not occur freely in nature. Instead, it is commonly found in compound form, such as sodium chloride, common table salt, which plays a central role in both biological systems and human industry. Sodium was first isolated in 1807 by British chemist Sir Humphrey Davy. Using electrolysis, Davy extracted sodium from molten sodium hydroxide, a groundbreaking achievement at the time. This not only proved that sodium was a distinct element, but also demonstrated the potential of electrochemical methods to discover and isolate new elements. In nature, sodium is abundant and widely distributed, though not in elemental form. It ranks as the 6th most abundant element in the Earth's crust and is primarily found in minerals and salts. Sodium chloride, NaCl, is the most familiar form and is highly soluble in water, which means it's present in large quantities in seawater and salt lakes. Other important sodium-containing minerals include soda ash, sodium carbonate, and natron, a natural blend of sodium salts, which have been used since ancient times. Pure sodium is a soft, silvery white metal that can be easily cut with a knife. It is highly reactive and must be stored under oil or in an inert atmosphere to prevent it from reacting with moisture or oxygen in the air. When sodium comes into contact with water, it reacts vigorously, producing sodium hydroxide and hydrogen gas, often with enough heat to ignite the hydrogen. This characteristic makes sodium both useful and hazardous. In terms of applications, sodium has many industrial uses. Metallic sodium is used as a chemical reducing agent in the manufacture of certain types of glass and in some specialized metal refining processes. It's also used in the production of synthetic rubber and dyes, and as a heat exchanger in some types of nuclear reactors due to its excellent thermal conductivity. However, the most widespread and familiar form of sodium is sodium chloride. Apart from its essential role in human and animal nutrition, sodium chloride is heavily used in the chemical industry. It's the raw material for producing chlorine and sodium hydroxide through electrolysis. These two substances are key ingredients in the manufacture of paper, textiles, detergents, and PVC plastics. Sodium compounds have many other industrial applications. Sodium bicarbonate, baking soda, is used in food, cleaning products, and fire extinguishers. Sodium carbonate is important in glass production and water treatment. Sodium nitrate and sodium nitrite are used in fertilizers and food preservation. Sodium sulfate is used in the manufacture of paper and detergents. These compounds demonstrate the versatility and utility of sodium across a wide range of sectors. Sodium also plays an essential role in biological systems. In humans and other animals, sodium ions are crucial for nerve function, muscle contraction, and fluid balance. Sodium is one of the body's major electrolytes and works together with potassium to maintain the proper electrical and pressure gradients across cell membranes. The sodium-potassium pump, a cellular mechanism that moves sodium out of cells and potassium into them, is vital for many physiological processes. Because sodium is lost through sweat and urine, it must be regularly replenished through the diet. However, excessive sodium intake is associated with health risks, particularly high blood pressure, which can lead to cardiovascular diseases. The World Health Organization recommends limiting sodium intake to less than 2 grams per day, about 5 grams of salt, for adults. In modern diets, most sodium comes from processed foods rather than table salt added during cooking, making public health campaigns and food reformulation strategies important tools in managing population health. In agriculture, sodium is less essential than other nutrients like nitrogen or phosphorus, but it can still play a useful role. Certain plants, such as sugar beet and barley, can benefit from sodium when grown in soils deficient in potassium, as sodium can substitute for some of potassium's functions in plant cells. In animal nutrition, sodium is more critical. Livestock require sodium in their diets to support hydration, nerve function, and milk production, and it is typically provided through salt licks or mineral supplements. Sodium's role in the environment is also notable. Large-scale use of road salt for de-icing in winter leads to sodium buildup in soils and freshwater systems, which can affect plant growth and aquatic life. Monitoring and managing the environmental impact of sodium-based de-icing agents is an ongoing concern in regions with cold climates. In energy and materials research, sodium has gained attention for its potential in rechargeable batteries. Sodium-ion batteries, a developing alternative to lithium-ion batteries, are attractive due to the wide availability and lower cost of sodium. Although still less energy-dense than lithium-ion versions, sodium-based batteries are promising for large-scale energy storage applications, such as stabilizing power grids that rely on intermittent renewable energy sources like wind and solar. Sodium vapor lamps are another interesting application. These lamps emit a bright yellow-orange light and are widely used in street lighting due to their efficiency and long life. The characteristic glow comes from excited sodium atoms emitting light at specific wavelengths. Although now being gradually replaced by LED lights, sodium lamps were a major innovation in public lighting for decades. From a safety standpoint, sodium must be handled with care, especially in its metallic form. It reacts explosively with water and can ignite spontaneously in air. Proper storage, handling procedures, and protective equipment are necessary when working with elemental sodium in laboratories and industry. However, sodium compounds like salt and baking soda are generally safe and widely used in daily life. In summary, sodium is a key element that plays critical roles in both living organisms and industrial processes. It is chemically active, biologically essential, and economically important. From the table salt on our meals to the operation of our nerves, from factory floors to battery labs, sodium is everywhere. Its impact on health, technology, agriculture, and the environment reflects its broad versatility and significance. As science and industry continue to evolve, sodium remains a vital part of the periodic table and a cornerstone of both nature and modern life.